Hello friends, this is Astha Sharma. This is the paper of MTech IT 2K21 4th SEM paper, NAD paper. Let's start our discussion. Question number 1. Find the root of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show their nature, whether they are convergent or divergent in nature. Assumption: let f of x equals to x square minus x minus 1 and f of 1 equals to negative and f of 2 equals to positive. Hence, root is between point x equals to 1 and x equals to 2. So we can take x0 equals to 1.5 as medium value. Let the function f of x equals to x square minus x minus 1. This is the solution. Here are the following equations g of x that can be made through f of x. Here we have a table for the selection of correct g of x. First, g dash x should be less than 1. If multiple value of g of x are less than 1, then choose the least one. For the selection of correct g of x, first, g of x should be less than 1. Second, if multiple value of g of x are less than 1, then choose the least one. Table for the convergence. Here is the table. The g of x equals to root x plus 1 should be taken for the fixed point iteration method. x0 equals to 1.5, x1 equals to greater than or equals to root of 1.5 plus 1, x1 equals to or greater than root 2.5 equals to 1.5811, and the process continue. Like x2 equals to 1.6065, x3 equals to 1.6144, x4 equals to 1.6169, x5 equals to 1.6176, x6 equals to 1.6179, x7 equals to 1.618001, as the error between x7 and x6 is 0.000101. Hence, root of x square minus x minus 1 is 1.618001. Question number 2. Find the solution of the system of equation using iterative method. And the equations are 20a plus b minus 2c equals to 17, 3a plus 20b minus c equals to minus 18, 2a minus 3b plus 20c equals to 17. We find the value of a, b, c in the respective equation by taking variables from one side. A equals to 17 minus b plus 2c upon 20. B equals to minus 18 minus 3a plus c upon 20. C equals to 17 minus 2a plus 3b upon 20. Let a of 0 equals to 0, b of 0 equals to 0, c of 0 equals to 0. A equals to 17 minus 0 plus 0 upon 20. B equals to minus 18 minus 0 plus 0 by 20. C equals to 17 minus 0 plus 0 upon 20. A1 equals to 0.85, B1 equals to minus 0.9, C1 equals to 0.85. By putting the values of A1, B1 and C1, A equals to 17 minus 0.9 plus 2 bracket 0.85 upon 20. B equals to minus 18 minus 3 bracket 0.85 plus 0.85 upon 20. C equals to 17 minus 2 bracket 0.85 plus 3 bracket minus 0.9 upon 20. A2 equals to 0.98, B2 equals to minus 0.985, C2 equals to 0.63. And by putting A2, B2 and C2, A equals to 17 minus 0.985 plus 2 0.65 upon 20. B equals to minus 18 minus 3 bracket 0.98 plus 0.63 upon 20. C equals to 17 minus 2 bracket 0.98 plus 3 bracket minus 0.985 upon 20. By putting A3 equals to 0.96225, B2 equals to minus 1.0155 and C3 equals to 0.06042 by putting A3 B2 C3, and by putting A4 equals to 0.961195, B4 equals to minus 1.0141, C4 equals to 0.6014. We will follow the steps till we get repeated approximate values. Question number 3. List out 4 disadvantages of Gauss elimination and 3 advantages of iterative method over the elimination method. The iterative method is superior to the elimination method due: first, computational effort is approximately 2n to the power 2 arithmetic operations per iteration, and if convergence is achieved in less than n iterations, it is significantly superior compared to the elimination method. Second, another important advantage of the iterative method is a small rounding error. The rounding error being the one committed in the last iteration. Thus, for ill-conditional system, an iterative method is a good choice. Third, in Gauss-Seidel method, we set xi equal to the newly calculated value of the iterative stored in temp. The disadvantage of Gauss elimination are as follows. First, the computational effort is approximately 2n3 upon 3 arithmetic operation in each elimination step. Second, the amount of bookkeeping necessary is considerable. Third, the rounding error may become quite larger, particularly for ill-conditional equation. Fourth, any spatial structure in the matrix of coefficient is different to preserve during question number 3. Write the algorithm for the Lagrange inverse interpolation. First, read number of input n. Second, read the value of x. Third, for I equals to 0 to I equals to n minus 1, read xi yi. Fourth, set sum equals to 0. Fifth, for I equals to 0 to I equals to n minus 1, set product equals to 1. For j equals to 0 to j equals to n minus 1, if I is not equals to j, product equals to product multiplicative y minus yi upon yi minus yj. Sum equals to sum plus xi multiplicative product. 6. Print sum. Question number 4. Evaluate the integration using the 3-point Gauss quadrature formula for the given abscissa and weight. Plus 1 equals to 0.77459,667, plus 2 equals to 0, plus 3 equals to plus 1, W1 equals to minus 0.555556, W2 equals to 0.8889, W3 equals to W1. Let A equals to 0, B equals to 1, X equals to B minus A upon 2, T plus B plus A by 2. Putting the values of A and B, x equals to 1 plus t by 2, dx equals to dt by 2. Substituting the value of x and dx in the f of x. F of t equals to integration limit minus 1 to 1 2 upon 4 plus 1 plus t multiplicative 2 dt. F of t equals to 0.555556 bracket bracket minus 0.7745 plus function of 0.7745 bracket close plus 0.888889 bracket function of 0 bracket close. Integration limit minus 1 to 1 2 upon 4 plus 1 plus t bracket close to dt equals to 0.55556 multiplicative to 0.493723 plus 0.27976 bracket close plus 0.888889 bracket 0.4 bracket close. Integration minus 1 to 1 2 upon 4 plus 1 plus t 2 dt equals to 0.78527. Question number 5. Write an algorithm for the Weedle rule for the 6 point. First, first, read start. Second, read end. Third, h equals to end minus start upon 6. Fourth, for I equals to 0 to I equals to 6, read yi. Fifth, s equals to 0.3h bracket y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. Sixth, print s. Question number 6. Write the algorithm for the Rangakutta fourth order expression. And the answer is first, def f def function of x comma y written expression. Second, read starting ending splits. Third, h equals to ending minus starting upon splits. Third, while starting is smaller equals to ending, k1 equals to h multiplicative function of x comma y, k2 equals to h multiplicative function of x plus h by 2 comma y plus k1 by 2, k3 equals to h multiplicative f a function of x plus h by 2 y plus k2 by 2, k4 equals to h multiplicative function of x plus h comma y plus k3, x equals to x plus h, starting equals to starting plus h, y equals to k1 plus 2k2 plus 2k3 plus k4 by 6 plus y0. Print x comma y. Question 6. Apply predictor corrector method to solve dy by dx equals to minus xy, comma y of 0 equals to 1 in step of 0.1 up to y of 0.2. And the answer is y of n plus 2 to limit p equals to yn plus 2h function of x n plus 1 by n plus 1 by n plus 1 limit c equals to xn plus h by 2 function of xn minus x1 comma y1 plus function of x n1 n plus 1 comma y n plus 1. By Hume's method, k1 equals to function of xi comma yi, x2 equals to function of xi plus h by 2 comma yi plus k1 h by 2, k equals to k1 plus k2 by 2, ki plus 1 equals to ki plus kh. Hence, y of 0.1 equals to 0.9975. Y of 0.2 equals to y0 plus 2h x function of x 0.1 y of 0.1 predicted y of 0.2 equals to 1 plus 2 multiplicative 0.1 multiplicative minus 0.1 into 0.9975, and y of 0.2 equals to 0.98005. Y of 0.2 equals to y equals to 0.9975 plus 0.1 by 2 bracket minus 0.1 multiplicative 0.9975 minus 0.2 multiplicative 0.98005. Y of 0.2 equals to 0.982712 is the corrected. We can apply corrector formula again for more accurate value by putting this corrected value as predicted value in the corrector formula. Thank you so much.